Every time you type in a text editor, there's a hidden dance happening behind the scenes that most programmers never see. Whether you're coding in VS Code or writing in Google Docs, your editor needs to handle insertions and deletions efficiently, and the solution is surprisingly elegant. Gap buffers are data structures that text editors use to manage text efficiently. Think of a gap buffer like a parking lot with a designated empty section that moves around. When you need to park a new car, the empty spots slide to where you are, making insertion instant. This is exactly how gap buffers work with text. The gap buffer maintains your text in a single array with an intentional gap of unused space. This gap always sits at your cursor position. When you type new characters, they fill the gap from left to right. When you delete characters, the gap expands. The genius happens when you move your cursor. The gap buffer shifts characters around so the empty space follows your cursor position. This seems inefficient, but it's actually brilliant for how humans edit text. We typically make many small edits in the same area before jumping elsewhere. Modern implementations optimize this further. Emacs pioneered gap buffers in the 1970s, and they remain relevant today. Some editors use piece tables or rote data structures instead, but gap buffers excel for sequential editing patterns. The buffer dynamically resizes when the gap fills up, doubling in size to maintain performance. This amortized growth keeps operations fast even with large documents. Popular editors like Emacs, some versions of Vim's internals, and various IDE components still rely on gap buffer implementations. The algorithm trades memory for speed, keeping extra space available for immediate insertions. Understanding gap buffers reveals why certain editing operations feel instant while others might lag briefly. If you want to understand rote data structures next, it is already on the channel.